All right. Unit 5, Lesson 1, Investigation 1. We're doing trig functions, but now we're gonna learn how to use those trig functions to find side lengths. All right. So to get us started, I have this triangle that I've drawn, and yes, this is a real 30-degree angle. Yes, David.
It's definitely
Unit 7. I can't say. I've been doing that all week. All right. So Unit 7. All right. I want us to get started by writing the ratios for sine 30, cosine 30, tan 30. Now, we're not calculating these yet, so don't take your calculator out and calculate these. I just want you to write the ratio. So just like we did yesterday. Remember we had theta right here instead of 30? You guys remember that? So this is my theta. I want you to write the ratios for sine 30, cosine 30, and tan 30. Just write them down. Write them down. Just the ratio, so like blank over blank. Blank's not a cuss word. Those are beeps. Nice.
You're welcome.
Remember SOHCAHTOA, right? It's over there on the board for those, yeah. SOHCAHTOA, help you out. All right, so sine 30. 30 is right here. Sine deals with which ones?
What?
Sine goes with which sides? Opposite and hypotenuse. So sine 30 is going to be 5 over 10. Cosine 30.
8.66 over 10.
Okay, adjacent over hypotenuse. So 8.66. And tan of 30. Opposite over
5 over 8.66.
Okay. So these are our ratios just like we found yesterday, right? Any questions on I got those?
Wait, what do you have to do this one?
Remember SOHCAHTOA, right? Sine is sine 30.
It's theta.
Opposite,
Oh,
30 is my theta. Okay. Opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse, and tangent opposite over adjacent. Okay. All right. So there we have the ratios. Okay, the next thing we're doing is we're going to calculate these. Now, in order to calculate these, you need to switch your calculator into degrees. Okay, because our angle measures are in degrees. To switch your calculator into degrees, you hit the mode button. It's right next to seconds. All right. Then you go down to the third line where it says radian and degree. Okay. Radian might be highlighted because that's how it comes on your calculator. All right. You need to move over and highlight degree and hit enter. So then degree is highlighted and radian's not highlighted anymore. Yes, I did show that on the YouTube video, so you need help with that. All right. So degree is highlighted. All right. Once you do that, hit second quit, and now your calculator is in degree mode. If your calculator is not in degree mode and we're using degrees, you're going to get really weird answers. Okay? You'll get negative numbers. You'll get numbers that are bigger than 1 for sine, and we know that can't work. Okay? So make sure your calculator is in degree. Anybody need help getting back into degree? Okay, if you're stuck on the mode page, hit second mode, and it'll take you back out. All right? Now what I want you to do is I want you to punch in your calculator sine 30. So hit the sine button, hit 30, and hit enter. What is it, David? 0.5. Now, sine 30 is 0.5, but over there I got 5 over 10. It's the same. Interesting. Now, did I take your calculators and draw this triangle in everyone's calculators last night so then the calculator knew that sine 30 was going to be 0.5 in this case? No. I didn't do that, did I? Okay. Remember what I told you yesterday and the day before? What determines the ratio? The angle or the sides? The angle, right? The angle determines what the ratio is going to be, right? So when I calculate sine of 30, it doesn't matter what triangle I have. If I have a 30-degree angle in my right triangle, then sine of 30 is going to be 0.5, right? If my sides are 20 and 40, it's still going to be 0.5, right? As long as I have a sine of 30, right? Now, when I made this triangle, I didn't just draw it and say, okay, this one will be 5, that one will be 10, right? You can't just say, okay, here's a 30-degree angle, this is going to be 4, and that's going to be 15. That won't work, okay? In order to have it actually be a 30-degree triangle, then these sides have to be the correct, okay? In order to know that these sides are 5, 10, and 8.66, I had to do some work to prepare that. Okay? Does that make sense? I can't just draw a triangle and say that's 30. All right? It doesn't work that way. Right? But if I have a triangle that actually has a 30-degree angle, then the ratio of opposite over hypotenuse will always be what? 0.5. I thought that's kind of cool. Maybe I'm a math nerd though. All right? All right. Cosine 30. Let's calculate that. So type in your calculator cosine 30 and hit enter.
I got it already.
0.866, right?
Yeah.
Okay. Now if I take cosine 30, which I calculated a second ago with the ratio, it was 8.66 divided by 10. If I do that division, what do you think we're going to get? 0.866. Once again, it's because our angle determines our ratio, right? Any triangle that has a 30-degree angle in it, cosine of that angle will be 0.866. Okay? The ratio between the adjacent and the opposite side will be 0.866. Any triangle has a 30-degree angle. Okay? Tan of 30, what's that? 0.577. Now, I'm not good at mental division, but I know this right here is going to be 0.577. Because I know tan of 30 for any triangle with 30-degree angle in it is going to be 0.577. Right, does that make sense?
Yeah.
So you guys kind of see now how what I was saying in the past 2 days about how the angle determines our ratio? You guys kind of see how that's all playing into our opposite over adjacent and our opposite over hypotenuse and all that good stuff? All right. Are there any questions about that triangle and what it's showing us? All right, it's kind of the culmination of the last 2 days. All right, any questions? Anybody? All right. Now, in order for this to work out, our calculators must be in degrees, so don't forget to do that when you're working at home or when we're taking a test or when we're doing our OYOs. All right. Now, why is this useful? Okay. Today is called Unit 7, Lesson 1, Investigation 1, Trig Functions, Finding Side Lengths. Right? So now that I know how to calculate sine, cosine, and tangent using my calculator, we can use those ratios to find unknown sides. Okay? So, first example, it says find y. Everybody see this example? Right? Find y? This is easy, right? Found it. Come on, no one's going to laugh?
It's not that easy.
I know, it's not that easy. If it's a test and I say find y and you put an arrow and say I found it,
Yeah.
I will laugh. I will laugh. I will even laugh out loud. Right? But you'll get 0.
Well, what if you put the arrow and put the answer?
Oh, then I'll laugh out loud and you'll get the 100%. Okay. All right. So if I want to find y, I need to use my trig ratios. Okay. Right here I have a little run-on sentence to help us figure out what we need to do. So if we're going to use trig ratios to find side lengths, this will help us out. So to find the side lengths using a trig function, you must pick sine, cosine, or tangent that uses the side you want to find, a side you know the length of, and an angle you know. Okay? So once again, to find side lengths using a trig function, you must pick sine, cosine, or tangent that uses the side you want to find, a side you know the length of, and an angle you know. So the 3 important things in here are the side you want to find, right? Side you know, angle you know. Okay. Of the 3 things I underlined, how many do I have to know? 2. How many am I going to find? 1. So essentially, I'm going to take sine, cosine, and tangent. I'm going to make an equation with 1 unknown. And I'm going to solve it. I'm going to solve that unknown. Sounds a lot like algebra, doesn't it? Make an equation, 1 unknown, solve the unknown. Okay. So in this triangle, my unknown is y. Right? I don't know y. I want to find y. Okay. Here's the angle I know. Here's the side I know. Right? We have 3 choices. We can use sine, cosine, or tangent, right, to find y. Any of those 3. Now, if I'm going to use sine, sine involves my opposite and hypotenuse. Well, y is opposite, right? That's what I want to find. Hypotenuse, do I know that? No. So can I use sine? No. Because I don't know the side, do I? I have 2 unknowns. cosine adjacent over hypotenuse.
No.
Okay, I don't know this, but it doesn't contain my y, does it? So which one do I have to use?
Tangent.
Tangent. Tan of 66 is opposite over adjacent. Okay? Angle I know, side I want, side I know. Right? Has the three things I need, doesn't it? Yeah? So if I'm going to find y, we're going to do tan of 66. Okay? Tan of 66 equals opposite over adjacent. Does that make sense? Yeah. Now my first step in this problem is to calculate the tan of the angle. Okay, do that first. Okay, please do that first. All right. So tan of 66 is what? 2.25. And now we have an algebra problem. Guys are jumping for joy, right? We love doing algebra. Yeah? Nice fist pump. I like that. All right. All right. So 2.25 equals y over 75. First step, get the 75 off the bottom, right? Since it's on the bottom, that means,
Times.
okay, it means it's being divided, so to get rid of it, we multiply.
You got your stars.
So multiplying by 75, we'll get rid of the 75 on the bottom. 75 times 2.25? Good, 168.75. And now we really found y. Okay. Does that make sense? No? All right, we'll do another example.
Why is it so big?
Why is what so big?
Why?
Why? Because 75 is big. Okay. Okay, we can have. And we know that our tangent was 2.25, right? Tan of 66. So I got to keep that ratio true. Okay, I got to make sure that ratio still works. All right? So that means y has to be more than double 75. Okay, so that way that ratio will work. All right, any questions about finding y? No? Okay. Next example. This says solve the triangle. Okay, those three words you'll probably come to hate. All right, solve the triangle. Because that doesn't mean just find one of the variables. It means I got to find all of them. Okay, so in this triangle, how many unknowns do I have?
2.
3. X, y, and
Theta.
theta. So when it says solve the triangle, that means you need to find all unknowns. Okay, both angles and sides. Right? So you got to find all unknowns. It does not matter which one you start with first. You can start with y, you can start with x, you can start with theta. Okay, it doesn't matter which one you want to start with. Right? Come on the screen. There we go. Okay. So it doesn't matter which one you start with first. I want to start with what? Okay, you guys okay with me starting with y first? Is that fine? Okay. Let's start with y first. Okay. So we're going to find y. Y is right here, right? What is y relevant to the angle I know? Is it my opposite side, my adjacent side, or my hypotenuse?
Adjacent. Adjacent.
It's adjacent, right? It's adjacent, it's next to. X is my hypotenuse, y is my adjacent.
So it's opposite.
What side do I know?
Opposite.
We know our opposite. So that means I have to use a trig function that involves my adjacent and my opposite. Tangent, right? Tangent is total, right? Okay? So that means we have to use tangent. So to find y, we're going to do tan of 30. Right? Tangent is equal to opposites over adjacent. So it equals 10 over y. Now the first thing I would do is calculate my tan of 30. Okay, so type in tan of 30, or you can look to what we did previous, because we already calculated tan of 30. And what is it? 0.577 equals 10 over y. Now this is a fun problem to solve, isn't it, Jakai? Because my variable's on bottom, right? How do I solve my variables on the bottom?
U to 5.57.
Times y.
We get the variable off the bottom first, so we multiply by
Y.
y. And whenever our variable's on the bottom, you multiply by it first, so then they cancel out. Now I have 0.577 y equals 10. Right? John, what should I do now? Give you a chance to redeem yourself.
Divide by 0.57.
Good. Divided by 0.577. And that means that y equals 10 divided by 0.577, 17.33. So it's 17.33. Right. Are there any questions on how I did that one? No, does that make sense, guys? Yeah? Okay, so now I found y, right? We know this is 17.33. And when you're doing a problem like this, guys, I would tell you to write down things on the drawing after you find them. Okay? If it's in your book, redraw your drawing on your paper and write down the sides after you find them. Okay? So it's going to help you out, right? Because now I see that I have my adjacent side and my opposite side to my angle, don't I? Right? And that'll help me figure out what I need to do to find x. Okay? Does anybody know how I could find x? Sine? Sine of 10, right? Or sorry, sine of 30 equals 10 over x. That'll work to find x. What else will find x? Cosine. Cosine of what, Doug? Okay, so cosine 30 will be equal to 17.33 over x. Right? How else could I find x? Brandon? Pythagorean theorem, good. We know 10 squared plus 17.33 squared equals x squared, right? So all three of those ways can find x, right? Does it matter which one I pick?
No.
No. Okay? Excuse me. It does not matter which one I pick. So let's try this one. All right, sine of 30 is what? 0.5.
What is that noise?
Cars
No.
on the thermostat. Okay. So 0.5 equals 10 over x.
Scary.
Now what do I do to solve?
Times x.
Multiply by x, because x is on the bottom, right? So I'm going to get 0.5x equals 10. What should I do now? Divide by 0.5. So x equals, what is it? 20. Right? Now some of you might say, well, I wanted to do the Pythagorean theorem because I really like the Pythagorean theorem. Okay, some of you might do that. That's fine. Okay? So let's try Pythagorean theorem. All right? Both of these are the same way to find x. You don't need to do both. You can just do one. Okay? So if you did that, you found x. Great job. All right? But if we want to use Pythagorean theorem, that's fine. 10 squared is what? 100. 17.33 squared is 299.29. Get it in my head.
It's not.
What is it?
300.33.
300.33? Man. That's something I was good in my head than I was. 300.33. Okay. Gosh, Sabrina. All right, that's fine. All right. Now, I combine these and I get 400.33, right? Right? Yeah? And then how do I solve for x?
Square root.
Square root. Square root of 400.33 is what?
200.01.
Oh, not 200.
Or 20.
20.01? Okay.
Also,
Now, is that exactly 20? Because here we found exactly 20. Is this exactly 20?
No. That's close enough.
Almost. It's close, right? Okay. What I'm trying to show you by doing this two ways here is that when we use the numbers that are given to us, we'll probably get an exact answer. When we use numbers that we found and rounded, right, we might get an answer that's a little bit different. Okay? If I went to 17.3 right here instead of 17.33, then we would end up getting like 19.98, I think. Okay? Still close, right? So if you and your classmate do a problem differently, and your answers are close, right, you're both probably right. Okay? That's why it's incredibly important that you show your work when you do these problems. All right, so then I know which way you did it, and I know what your answer could be. Okay, does that make sense? And I know how much you rounded. All right? If you just do them in the calculator, I won't know how much you rounded. All right? So then I'm going to be looking for that exact answer. If you show me your work and you get something like this, then I'll know. I'll know what you did. All right, does that make sense? Okay, last thing to solve this triangle, what is it?
Theta.
Theta, right? Save the easiest for last, right? We know all of our angles add up to 180. So to find theta, we know 180 equals 30 plus 90 plus theta. That's the right angle, so we know it's 90. Okay. What's 30 plus 90? 120. So 180 equals 120 plus theta minus 120. So 60 equals theta. So congratulations, you guys just solved your first triangle.
You have to do all that work just to get the answer.
No, we got 3 answers. Okay, we got theta, right? We found y, we found x, we found y. Right? We found 3 answers. So you don't have to do them in this order, right? You could have started with x first, but then you couldn't have used Pythagorean theorem. You could have started with x first. You could have started with y first like we did. You could have started with theta first. Okay? So you can do them in any order you want to, right? But we found all 3 sets. Right? All right, any questions? Any questions?
No, actually. How would you do it if you started with theta first?
If I start with theta first? Okay, so we knew theta was 60, right? So I'm just going to erase all this, assuming we didn't do it. Okay, so we know that's 60 now, right? So now what we can do, we can use sine of this angle if we want to, or cosine of this angle, or tangent of this angle. All right? So we could do tan of 60 equals opposite y over 10. Okay? And then I'll calculate tan of 60, I'll multiply by 10, and I'll get my y. All right? Good. And we can use this to find our x. We could do cosine of 60 equals 10 over x. Okay? So finding that one first just gives you more trig functions that you can use. Okay? Does that make sense? Yeah, good question. Anyone else? Anyone else?